There's a couple of questions I'd like to dive into after that. But first, before I do that, Tristram, your perspective is, you've been in the industry now, you've seen, as you say, the early Fortran work right through to more modern day use of software. In the process of that transition, I'm presuming that engineers, and younger engineers especially, are missing something that they otherwise would have got involved in or done or learned in the process. They dive straight into software, often on day one of their jobs. Do you feel that they're missing any kind of fundamental knowledge that means that actually they're sort of just driving black boxes, or do you think they generally understand what they're working with and the tools are transparent enough to enable that?
We briefly talked about this before joining the panel. I fundamentally believe that, right, so if I go back to the very beginning when I started, you had to do all your calculations by hand. You spent your time sitting at a desk with a pencil, doing WL squared over 8 and working out how many bars to put in a concrete beam. Then along comes a computer and it does that calculation for you. So you spend a fraction of the time doing that and you get a whole lot of time to do a lot of other things, which is a huge benefit. But some people feel that by not doing the maths yourself, you lose touch, a feel for what the result is and what's happening. And I think that's a matter of attitude, not a matter of tool. The fact that using your computer you can do 100 beams when you used to be able to do 10, you ought to be able to learn 10 times more about the feel and quality of the outcome. Particularly if you interrogate what you've done using a different tool or a different bit of software or making a simple model as well as a complicated model. I don't think we've taught people properly over that intervening period. Even today, I don't think we're teaching engineers to use the digital environment as a method of exploration and interrogation, as opposed to it's just being given to you, do the answer. The problem with do the answer is the answer is often wrong. And what do you do next, if that makes sense? So I think I don't blame the tool in any way, or the environment even, but I do think it's about the attitude of us, and particularly the senior members of the profession, and how they're bringing up the more junior ones and forcing people, if you like, to explore more and get that feeling for, no, that just isn't right. If that's the answer, then I've done something wrong in the process because that's not the right answer. And we talked about teaching more physics and less maths as a way to get more of that, how do things work, as opposed to dealing with the numerical abstraction, that represents how they work.
Really interesting. I suppose, do you feel, and please, if anyone in the audience has got any points, please raise your hands and say, but do you feel that, there's obviously, again, you're in a unique position because you do understand this stuff at a deep level. You've been involved in the programming process yourself. But I wouldn't say that every manager or every senior staff member in a company managing younger engineers who are driving these tools, and as you say, designing hundreds of columns in seconds, necessarily knows how to inspect the data in an intrusive way. I feel like we almost do we sort of blame them, but at the same time, I feel we do them a disservice because they're not necessarily themselves being given the skills to understand how to explore any type of model, a Tekla model, whatever the software might be.
Or even a BIM model.
Or BIM model. Precisely, yeah. It's kind of just handed off and left, and it's trusted that it will be done correctly. Would you agree with that, or do you think there's anything we can do as an industry?
I talk about a thing called a digital divide, between those that can and those that can't. And the problem is that those that can't have all the experience, and that needs to get into the project and be exposed to everybody. But because there's a different tool set being used by the two different, you don't get that transfer as readily. But I say it's always the non-digital, if you like, the older generation with the experience, who have to force their way into the project, have to learn how to read a BIM model, have to understand at least the output from the ETABS model, even if they don't understand how to run.
I would suggest that on the other side, there's also potentially next generation people that kind of are coming up in this environment are there's new skills, there's new just kind of latent, like I think like children that have grown up just playing video games, have such it's studies have proven they've got a totally different way of mentally visualizing three-dimensional space, in terms of, from just running around video game maps and stuff, they understand how space is constructed in that way. That I think when we're talking about our models and that you, like say back in the day, you might have just been working on a single drawing, you know, on a board, and you're just focused on that one aspect of the project. Actually now, we all have a much more holistic view of the project. You know, every member of the team has the whole project almost in front of them, and they're part within the bigger picture. So I think that there must be some, you know, people coming through now are actually have a bit more of a full understanding of the project around what they're doing, as well as that they're able to do more within